Morning. My name is Ainun Rahmawati. This time I will explain about the result of our research entitled Short-Term Prediction of Bus Station Plate Number using a combination of BiLSTM models. So the background of this research is the first one, bus stations are the center of urban transportation infrastructure that connects various destinations with bus transportation services. Understanding historical trends in the number of arrivals and departure at bus station is an important step in making accurate prediction. Prediction result can help bus terminal managers to plan and manage services more effectively, ensuring adequate availability and accessibility for public transport users. Many predictions models at the bus station have been carried out by adopting various models according to the dataset and prediction objectives. The problem of predicting the number of arrivals and departures of a bus station fleet can include challenges that affect the accuracy and usefulness of prediction. Prediction models require large data processing, complex statistical models, or technical limitation in data processing and analysis. Then, predicting bus station fleet numbers requires a holistic approach using sophisticated data analysis techniques and appropriate predictive modeling. The short-term prediction of the number of bus station fleets using time series data is proposed based on the result of the best mean absolute percentage error or MAPE evaluation values from the comparison of the bidirectional LSTM BiLSTM convolutional neural network, BiLSTM transformer, BiLSTM informer, and BiLSTM reformer. The performance of the short-term prediction model is compared with hidden layer variations to obtain the best model. The best model will be used to predict the number of 6 types of bus station fleet, the correlation between prediction and the relationship between prediction for the next 30 days. So this research can propose prediction model and prediction result have never been carried out at a bus station before. So the station managers can use it to optimize fleet use, operational planning, cost saving, fleet maintenance, crisis management, and short-term planning. We will using the methods such as data collections, which come from reports on the number of arrivals and departure of the bus station fleet for 3 years at the Giwangan Type A bus station, Yogyakarta, Indonesia. And the report is made into a dataset in CSV form consisting of the number of fleet arrivals and departure from intercity, interprovincial, intercity within province, and city transportation. Google Collaboratory on Mac OS Venture 13.5 is used to run the Python programming language with the TensorFlow deep learning framework into the proposed prediction simulation environment. Data processing with min-max feature scaling was first carried out to divide training and testing segments. BiLSTM, BiLSTM CNN, BiLSTM transformer, BiLSTM informer, and BiLSTM reformer models run a training dataset with different hidden layers to find a prediction model for the number of arrivals and departures of the bus terminal fleet. The prediction and training dataset are compared and MAPE evaluates the prediction accuracy. The best prediction model based on evaluation values and stability testing of model performance to predict the number of arrivals and departure in the bus terminal fleet was produced by the combination comparison architectural model. The lowest evaluation value and relatively fast time for model experiments to find the best model. Different simulation environments are possible to obtain different results. So here is the scheme of the method. So we input some data, historical data and data processing, and the process including training data, feature selection, testing data, and then we test the model. then the training the model, and then it will be evaluated by MAPE, and then the result is we have the model in output. The BiLSTM is a type of neural network designed to process sequence data in a more effective way than conventional LSTM. It produces two hidden states, named one forward LSTM and one backward LSTM, and each time step T, which are then combined. The performance of the proposed prediction model will be assessed from the MAPE evaluation matrix. The MAPE divides each error based on each request, and the value itself close to zero is an accurate representation of model performance. For the result and discussion, we use the dataset, which contain the number of fleets based on daily arrivals and departure at the Type A Kiwangan bus station in Yogyakarta, with the format on 01/01/2021 for the January 1st, 2021, and then 09/30/2023 for the September 30, 2023. And there are 994 CSV file types for pre-processing data, and the dataset used is private data that cannot be published to the public. So the min-max feature scaling divided 80% for training data and 20% for testing data. The LSTM tuning parameters used are activation hyperbolic tangent, dropout 0.2, apoc 0, batch size 16, verbose 1, and optimizer ADAM. The hidden layer variation carried out are 0 hidden layers, 2 hidden layers, and 4 hidden layers. The MAPE is used to evaluate prediction models with the lowest value and relatively quick time based on experiments to find the best model. The LSTM informer prediction model is the fastest model, but the evaluation value is not the best based on the MAPE evaluation matrix, as can be shown in the table 1 upside. And you can see the color both in the light yellow and dark yellow. So that's the final result of the model. Then the sharing, training, and testing data is commonly used to ensure the model has enough data to learn, can be tested with data not saying during training. Experiments with 5 prediction models were conducted to test whether the combination of BiLSTM with other methods would improve prediction performance. Too many hidden layers can cause overfitting, which makes the model too complex and does not generalize well to testing data. And more complex models with more hidden layers tend to be more accurate, but require more time to train. As you can see in the picture, it shows that time series decomposition is used to analyze fractions of time series data into several simpler components in order to identify and isolate patterns in the data. The observed component displays raw data from 6 types of daily fleets arrival and departures, which are accumulated monthly starting from January 2021 to September 2023. Fluctuations in the increase and decrease in the number of fleet departures and arrival at the bus station occur constantly throughout the period. Fluctuations in the number of arrivals and departures of the bus fleet occur constantly throughout the period, reflecting the high dynamics of transportation activities. Time series decomposition becomes an effective tool for analyzing and understanding the underlying components of complex data, such as the number of fleet arrivals and departures. Identifications of trends, seasonal patterns, and random fluctuations can gain more insight into transportation dynamics and make better decisions to optimize transportation supplies. Here is the picture of the distribution of residuals. So the distribution of dataset errors are the result of the proposed prediction model is shown in the distribution of error graph. Most of the dataset errors are around zero, as seen from the peak of the bar and curve at zero. This is an indication that the proposed prediction model is very accurate because larger errors rarely occur. The error distribution shows that the majority of errors are around zero as an indication that the proposed prediction model is very accurate for most of the data. Positive skewness with a long tail to the right indicates the presence of several large errors that have not fully captured the data pattern in the proposed prediction model. This can be due to data complexity or anomalies that are not captured by the model. The error distribution provides valuable insight into model performance and areas that need improvement to improve overall prediction accuracy. The number of arrivals and departures of the city transport fleet is predicted not to increase or decrease. The number of fleet arrivals and departures at intercity, interprovincial, and intercity within province is predicted to decrease from the 1st to the 6th, after which it stabilizes, no decrease or increase. This means that it is predicted that the number of intercity, interprovincial arrivals will decrease more sharply compared to the number of intercity, interprovincial departure. The stability of demand for intracity transport is quite consistent due to well-established travel patterns and the lack of seasonal fluctuations or other external factors. Declines in intercity within province and intercity interprovincials can be caused by travel policy factors, seasonal changes, or fluctuations in demand for transportation services. The sharp decline in the number of arrivals compared to departure for intercity interprovincial fleets reflects a decline in demand for travel between provinces, or the presence of external factors that influence the number of passengers arriving from outside the province. Positive correlations in red and negative correlations in blue for 6 predicted results for the number of fleets at bus station are presented in the correlation matrix heat map, as you can see in the right side. There is 1 positive correlation, 2 weak positive correlation, 2 strong negative correlation, 8 weak negative correlation, and 2 uncorrelated ones. There is no correlation between city transport arrivals with intercity interprovincial arrivals and city transport departures with city transport departures. The strong positive correlation between city transport departures and intercity interprovincial departures shows that increases in departure in one category tend to be followed by increases in another category. A strong negative correlation to an increase in one category tends to be followed by a decrease within the category that may be due to shifts in transportation demand or changes in travel patterns. Weak correlation, positive or negative, means there is a relationship, but it is not strong, which may be due to the influence of the variable coming from other factors that have not been identified. The correlation of the 6 resulting predictions can be used to support better decision making for fleet planning and management, as well as to understand more deeply the dynamics of community mobility. So here are some conclusions. The first one is short-term prediction of 6 types of fleet arrivals and departures at bus station, and correlation between predictions can be carried out by the BiLSTM prediction model and a combination with CNN transformers, informer, and reformer. The best prediction model was found in BiLSTM transformer based on an MAPE value of 0.2211 with a relatively fast time. Short-term prediction of 6 types of fleet arrivals and departure at the bus station in the next 30 days can be carried out simultaneously by the BiLSTM transformer model. The peak of the bar and curve is at zero, which is an indication that the proposed prediction model is very accurate because larger errors rarely occur. There was one strong positive correlation, two weak positive ones, two strong negative ones, eight weak negative ones, and two uncorrelated ones. Prediction result can be used to support better short-term decision making in fleet planning and management to understand more in the dynamics of community mobility. And the last one is the prediction models that can capture all time series data patterns to minimize error distribution are the next development. That's all for today. Thank you for your attention.